next Sunday, all of it?
No. We're going to get, what's today?
Today's Tuesday.
Today's Tuesday, so we'll have notes today. So that's assignment.
Yeah.
Tomorrow, nothing.
Yeah. And then
Thursday.
Yeah, 2 things. That'll be good.
So that means, yeah, 3.1, 3.2 stuff will be due Sunday.
I think that all of us should start both us have Monday off for the rest of forever.
Rest of forever.
And the rest of
Okay.
forever.
So I want to make sure we don't run out of time. Again, we started with this right here from the Desmos, that we got these 3 rules. We know this notation, R, sub, whatever is written there, that's how you write that. Okay. So this is basically just definition. So this is not an example of what we're going to be talking about. What happened from this shape to that shape? It shrunk. Okay. So when you do reflections, the item shouldn't shrink. Okay. It should be exactly the same, except it's flipped, right? So it's going to be a reflection. So the word that they use is, and that's what goes right here, is rigid motion. So that also goes on here. So rigid means like it's stuck, right? So I don't know why. Maybe it's a little bit morbid, but what word means like frozen? That has rigid in it.
Rigid.
Cold. Winter.
Rigid.
Rigid. Okay. What happens when a person dies?
Rigor mortis.
Rigor mortis. Okay. And what does rigor mortis mean? No, it means you're frozen, right? Okay. And if I move that body that's frozen, no matter where I move it or reflect it or do whatever, it's still the same shape, same everything.
Well, what if it's like really long, like
What if you like?
I guess what happens to
Yeah. Okay. Moving on. This is pretty straightforward and simple. It asks, is it rigid motion, yes or no? A is what?
Yes.
No.
No idea. B is no.
Okay. Okay, I like Hope's idea. Let's jump down to this and say no. Why is that a no?
Because it's exactly the same as the first slide.
It's bigger.
Yeah.
Okay. Yeah. Yeah. So the other one, I think it would be a good idea to I'm going to take a sheet of paper and I'm going to write over top of it and sketch it. If I can see it, I can't.
It's not the same.
It's not the same. Why?
Because when you look at it, this one has a 90, like, it has 2 almost 90-degree angles. The other one does not.
Okay.
What's that?
Wait. Oh wait, they are the same. Huh.
So Miss Bricker gave me this paper, which is funny because it's exactly for this. So I can sketch it, my shape on here.
Tracing paper.
Yeah.
Tracing paper.
And then if I put it on the other shape, it's got to land perfectly on there. What would you say?
Yes.
So that's a yes.
It's crazy what perspective does to your shape.
Yeah. It definitely looks different, doesn't it? But it's the same. It's rigid. It didn't get bigger or smaller or get twisted. Okay.
Are we going to be able to have that?
You won't need it. Sure. If you need it. All right.
Move the body around.
Reflect. Okay. So here comes the mirror. I take this mirror and I put it right on the dotted line. Okay. And I keep saying mirror. And I don't know, maybe I'm pronouncing it wrong.
Oh, but I can see it in there. Oh my God.
This is weird, dude.
This is called, see this word right here? Mira.
It's in this game.
Okay, so mira, or I think most teachers just call it a mirror. even though that might not be the right way to pronounce. This is this mathematical thing. Someone came up with it. Everyone's like, cool, what do you call it? And that's what they named it. So the way that it works is if I look at it at an angle, and I can't really display it, but if I look at my shape and I'm looking at it down here at an angle, I should be able to draw it on the other side. Using a red pen is probably not the color I want to use. And you should be able to see it and be able to draw a pretty good, pretty close reflection.
Not 4D. The world is 3 dimensions.
It's pretty common to name this point here. Someone want to guess what we name it? H prime.
Because you're reflecting.
G prime. It's the new H, it's the new G, it's the new F prime. Say again?
I've been thinking that since the first time I heard it.
Yeah.
I get it.
I'm going to take my mirror and I'm going to just use it as a straight edge and connect my primes and my regular letters. And hopefully we notice something. I just use it as a straight edge.
It makes another shape.
Yeah, it looks like a 3D shape, doesn't it?
It looks like a triangle.
All right, this is what we're supposed to notice, or this is what the book tells us, that these angles right here are all 90 degrees. Okay. Also, that this segment right here is congruent to this segment right there. So the line that cuts it in, or the reflection line, is equal distance from H and H prime. Or you might call that point the what? Bisector is a good word. Midpoint is the one I was looking for, but both of those are true. Same with G, the G prime. So I put 2 dashes there to say that those are congruent. And then what am I going to do on F to F prime? 3 little dashes to indicate that those are congruent to that. Okay.
Like, what if your drawing it is not perfectly equal, so you just put the dashes on show?
My triangle is awful looking. If I was asking you to do this on a test and you did this, I'd be happy. Okay.
Even if it looks that bad.
You're so nice.
I know. I redraw mine like 7 times. But it was great.
This is a great head.
Oh my gosh.
All right, so now they're going to ask us to use to explain what's going to happen. Okay, so they're giving us that triangle ABC has these vertices, and then we're going to do this reflection, and then we got to identify the vertices of A prime, B prime, and C prime. First, A prime, B prime, C prime. And that Desmos kind of helps us out here because we learned that if you reflect across the X, the Y is opposite. Okay, so I'm going to start with the X because the X doesn't change. So that was easy. And the Y is opposite. So I think it's -6, +2, +4. If you get confused and it's the test and you're like, man, I can't remember what that rule was, I would sketch and put 1 point. So like 3, 5. And if I'm going to reflect this across the x-axis, then I know that the point is now here. So I can see pretty easily that 3, 5 became 3, -5. And then I go, ah, yes, I remember the rule.
At first, when I saw it, I was like, so if it's reflecting upon the x-axis, then when it says like our x-axis, that's what stays the same.
Yes. Okay. So whatever you put in your brain to remember how this works, it's always good if you can come up with one little example to kind of to bounce back on. If you could grab all the math tests that I've ever taken, when there's questions like this, you'll see random weird things off to the side where I'm going, is that what the case is? Yeah, I'm kind of proving it to myself. A prime, B prime, C prime. Okay, so this one says to reflect across the y-axis. So if I draw my little shape and I say, okay, here's 3, 5, and I'm going to reflect across the y, that becomes over here, and that becomes -3, 5. So I've just convinced myself, okay, that means that now the y stays the same, but the x switches signs. So 5, 6, -1, -2, 3, -4. And another thing you could do, if this was for $1 million and you had as much time as you want, I would graph all these points. And then I would graph all these points and I would look at it and ask myself, is that a reflection? Okay? Because you could do that, you could graph it. In the textbook, that's how they kind of solve this, is that they graph it and then they look at it. Okay? But we know that rule, so we can kind of bypass that. So they can give us the rule and ask us what happens, okay? Or they can give us the points and say, this is the reflection, you come up with the rule. So we know that that line is where in relation to our points, our primes. Where is that line in relation to our points? I'm going back. Yeah. Where is that line? We're going to get to y equals mx plus b, but where is that line in relation to our points? It's in the middle. So we need to find the middle. Now, if I asked you to write the equation of this line, okay, how do you write an equation of a line? Y equals mx plus b, you need to find the m and the b, but how else could you do that? Okay. If I gave you 1 point, would you be able to write the equation of a line?
Yes.
You need 2 points to figure out the slope. So we need to find what? 2 points. The points are where? In the middle. The points are in the middle. We need to find 2 midpoints. So I'm going to go back to this, and I need to find 2 midpoints. How many points did they give us? How many sets? They gave us 3 sets or 6. So you can pick whichever sets you want, and we need to find how many midpoints. We only need 2. Okay, you forgot the midpoint of equation? Midpoint is the what of the point? What word did I use? Average. It's the average of the points. So if we want to find C and C prime's midpoint, okay, it's going to be adding our x's. So our midpoint is 3 plus -8. If it's the average, we divide by 2. And 8 plus -3 divide by 2. And then we need one other midpoint, so let's clean this up. 3 plus -8. -5 divided by 2. -2.5. I like the decimal myself too. 2.5. Do we have enough? How do we get the other point? Can I do D or do I have to do E? What did you say? It doesn't matter. Okay? You're like, I just like the letter E. Are you boycotting? Okay, all right. Don't get mad at me. I'll do D. I switched to D. I switched to D. So 4 plus, we're moving on. And 6 plus, did I do it wrong? Oh, goodness gracious. Be nice. 5. As long, hopefully you're not writing in pen. And then 12 plus -5. Does that bug you that I put plus negative next to each other and I don't put parentheses?
I did it, but
That's what I write.
The 7th grade textbook's like, this is bad notation. Doesn't bug me though. Yeah.
But I still -7
It's
So it-
3.5, negative 3.5 and 3.5.
-3.5 and 3.5. Sorry, that's so small. Let me rewrite it.
I don't care about it anymore.
we're not writing it.
So now we found the midpoints. Now we have to find the equation of the points. Okay? To write the equation, just to remember we need, oh my gosh, y equals mx plus b. We need to have our m and our b. So how do we find our m? Change of y over change of x. So our m equals, our y is 2.5 minus 3.5 over my change of x, which is -2.5 minus, this is when I'll put a parenthesis. Why do I insist on a parenthesis there?
Because it will end up
Yeah, because a minus minus, as sloppy as I write, it might turn into just 1 minus.
It's minus 1.
-1
That's the whole thing.
over
1.
+1.
So it's -1.
So it's -1 is our slope.
So y equals -x plus b.
So y equals -1x plus b. I like that you don't put the 1 there, but Algebra 1 ninth graders would freak out if you didn't put a 1 there. Be nice. Okay, and then how do we find what our b is?
Plug in the X and Y values.
Which ones?
The original,
Which one?
like C3 plus 0.
Okay, do I plug in this one or do I plug in this one? It does not matter.
I gotta plug in the original. That's the name. You can plug it either.
We're trying to find the line of the midpoint.
So yeah,
Oh.
If you use one of these, you're finding the line that creates.
that's not good.
Then that's not what we want. Yeah, so we're going to plug in, which one do you like, the first or the second?
2.5.
I just listen to Mark because he scares me a little bit.
I mean, it scares me too.
You will throw his head there.
It's Mark.
Yeah. How do you not scare anybody?
What do you get?
Mark will throw his pet there. It is 0 equals b.
B equals 0 or 0 equals B. So then our rule is it's a reflection of y equals negative. You don't want me to put 1 there?
No, don't put 1.
Okay. Do you want me to write plus 0?
No.
Okay.
So let me also go backwards. If I gave you this rule and asked you to move this point, okay, it says y equals whatever x is, but switch its sign. Vice versa, y equals x, but switch its sign, okay?
Yeah, but
So that rule works both ways.
but they also flip, like, so on D normal it's 512, but then D prime is negative 5.
So let's start with 5.
Reflection Y,
Yeah.
and negative X, and reflection X.
I don't know.
Alright, pause.
Look, I wrote this.
I know, you're the best. Okay, so look, it says 5. To get, just focus on that. If I plug in what X is 5 down here, then that means Y equals -5. Just looking at the 5, and that's telling me that the Y equals -5.
Oh.
It makes perfect.
Pause. Okay, then to figure out the other one, I'm going to plug this in for Y. If Y equals 12, then X equals -12. So you're plugging in this number into our equation to figure out what the other one is.
Well, we still have to do all that work.
Yeah.
Why did we do
Okay.
all that?
Pause. So I'm saying, had I given you this in this rule, how could you have given me this? You plug in the X into the equation, it tells you what Y is. You plug in the Y into the equation, it tells you what the other one is.
Yeah.
This rule works for both the X and the Y.
So is this like the triangle?
Figure out why it's
like
To figure out the rule, yeah. Well, I'm saying if it was a different problem. This problem said find the rule. What did I do? That's the rule for this problem. There's a rule for every problem.
For the x-axis, would it be y equals -y, and for the y-axis, would it be x equals -x?
X-axis would be
X equals x and
y equal.
y.
There's no. You can't do that on that one. Okay. Let's talk about that later. All right. Now that you, let's jump past this one real quick and just look at this real quick. This is kind of fun. So if I want to hit the number 1 ball with the cue ball, which is the white ball's cue ball, and I want to hit this ball, and it says I'm not trying to get it in the pocket. I just want to hit it perfectly without hitting any other balls. So what we do is I'm gonna aim this way. Okay. So what I'm gonna hit this rail. So what I'm gonna do first is I'm going to, and we're gonna run out of time, but that's okay. I'm gonna draw a line right here. Okay. I drew a line right here. I took my mirror and I put it on that line. And I'm gonna draw the reflection of the number 1 ball, which is right here on my reflection. If this is cheating, then every professional pool player cheats. And then I connect the white ball to my reflection. And that's exactly where I need to aim for on my rail. If I aim exactly for that, it's going to bounce perfectly back and hit just that ball.
I'm never gonna lose it. Oh, again.
You're welcome. So,
Pulls out this. Wait.
I connect my pool ball with that. I'll do a better job of finishing explaining this tomorrow. For funsies, extra credit if you can walk in and have this one done tomorrow. Homework is online 3.1. Tomorrow is a work day. Mirrors, I would love for them to show back up on this desk. Please and thank you.
So that will make that problem a lot simpler.
What's that?
You are upside
Hey, Mark, you get this today, right? You said you want to take it.
Oh, I'll take